All right, I just caviared some dinner, and hopefully, I think it's arriving in like 20 minutes, and so hopefully we can finish this part 2 of day 3. That's my challenge, is to finish it before the caviar arrives, while drinking this glass of wine. Here we go. Let's do it. Nope, not what I want. Having a code, day 3, part 2. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop. After all, determine the number of trees you would encounter if for each of the following slopes you start at the top left. So same traversal that we've been doing. We already checked this one. What do you get if you multiply together the number of trees encountered on each of the listed slopes? Okay. So it's going to be like 7. In the above example, these slopes would find 2, 7, 3, 4, and 2, 3, 36. So let's write a quick test for this. First of all, we need to abstract this this method into. I'm going to abstract this away into a function that can calculate, like, get the number of trees given a certain delta x and delta y. I'm going to call it count trees for terrain, and then this is going to take in a terrain, toboggan terrain, and then delta x is an int, delta y is an int, and then we just want to factor essentially just all of this here, and then it's going to return the tree count. And it'll give us an int. Okay, so now we can vary the delta x here, still count the trees, and then just loop through the terrain. And since we did a good job, I did a good job of separating out the concerns here. So the terrain is separate from the delta x and delta y, and then we're keeping track of everything separate. So it's a good, solid approach to this problem. What I'm going to do is just make sure that this method performs as expected. So we're going to give it delta x and delta y. Tree count should be 237. Val tree count, we need to save that as this variable. And I am also going to do the same thing here. Just run all these tests and they should pass still, because really we just took that same code and factored it into this method. Okay. I'm going to write a test for this handle part 2 to example input. Oh, I see. Okay, so this is going to be for the example input that they gave us. Oh, caviar, it's picked up. It's on its way. Okay, we got like 10 minutes to finish this. Let's do it. So write 1, down 1. This. Oh, so this might actually, we need to parse the terrain differently now, given the delta x and delta y. So I might actually, I think what I'm going to do is, I'm going to actually, I think I'm actually going to factor all of this in. So I'm just going to have delta x, delta y, and then the file name. This is, yeah, okay. Whatever. This method is a little bit too abstract. I think it's doing too much, but I'm not going to worry about it. I'm going to just call this terrain. Terrain file name. Terrain file name. And then this is going to handle terrain file name. I'm doing this so to explain what my train of thought that I just had is the way that we parse this depends on the delta x and the delta y, because we need to determine how many times we need to repeat this input and concatenate these lists together. And so we really need to have that factored in as we're counting the trees for this terrain. So let's factor this. Just to be extra defensive, I'm gonna just make sure that these tests still pass. It's really quick to do. Handle full problem input. What is this? Empty collection can't be reduced. I don't. Oh, day 3 full.txt. This is why we run our code. Caviar is approaching. That was really fast. Okay, we're good. Now, this example input. I'm just going to do this as a list of, and I'm going to split the screen here. So val deltas, or I'm going to do val results. Oops, val results equals list of, and I'm going to pass in maybe count trees for terrain. File name is going to be just day3.txt. Count trees for terrain file name, and then my delta x is 1, delta y is 1, and then I'm just going to make some copies of this. The latest version of Kotlin allows you to have these trailing commas, and the compiler won't complain, which is convenient. So delta x in this case is going to be 3 and 1. 5 and 1, 1 and 2. So results dot, we're going to use a reducer. And our A and B, and then it's just going to be A times B. We're going to just take the product of those. 336. I'm just going to call this answer is this, or I'm going to just call this the product. Product. And then product should be 336. Was not. String index out of range, 25. This may mean that we have an issue with our num repeats code here. Not a big deal. So failed at 33. So let's just take this as an example. Delta x is 5, delta y is 1. So in 11 steps, if that's the case, in 11 steps with y, this is going to be going over 55. And so we obviously only repeated it. I'm just going to write a test around this for just a kind of a temporary test. Num repeats test. So really just thinking this through, what we want for, if it's going down 11, it's going to be going over 55 in that time because the delta x is going to the right 5. And so in that case, we're going to want to repeat this 1, 2, 3, 4, 5. Since this is 11 wide, this needs to be repeated at least 5 times. And clearly we were not doing that. This was repeated less than 3 times, right? Because the string index out of range is the x coordinate. So let's take a look at this. We're expecting this num repeats to be 5 for this case. What did it decide? Two. So the repeats really should be driven by the x. How far is the x going to move? In the time that it takes y to get to the bottom, how far is x going to move, right? So input.size divided by delta y, that gives us the number of steps to get to the bottom. So we really want to multiply this by x, right? This is going to be how far, this will give us how far x moved in this time. In this number of steps that we took in the y direction, how many steps did x take? And then we really want to divide that by the, number of characters in the row, right? So it's going to be, that's going to be divided by input 0.length, which is the number, that's the number of characters. And we might even want to do a ceiling of that to round it up. I think Kotlin has some helper methods. Replace with ceil, okay. Is this complaining? Hang on, why is this complaining? It needs a double. Okay, fine. To double. I'm just going to convert these to doubles. Is that better? It is a double. What more do you want, IntelliJ? Can I just do, here's what I'm going to do. I'm just going to take this whole thing and make it a double. That'll be cleaner. I'm going to take the ceiling of this and then .to double. And then parentheses. Why is this still complaining? Required double. Am I missing some parentheses here? That is my caviar. I guess I'll bring it back to an int. Required double. Found int. Why is this needing to be a double? huh? I'm just gonna do this real quick and then input dot size. Times delta y. Why does this need to be? Length is an int, delta x is int. These should all be integer division. Is there something? Okay. So what if I convert this to a double? Okay. Take the ceiling of it. Is this redundant? I suppose I could just make this inclusive. That would also, I think that would effectively be the same thing. That's my caviar. I'll be right back. Yeah, really the purpose of this is to be liberal about how many times we're repeating here. We just based on this delta x and delta y. Why is this suddenly complaining though? This is not making any sense. It literally just oh, I see, I'm missing a parenthesis. Here we go. Okay, I think this is fine. So in this case, we're expecting 5, right? 5 repeats. Okay, num repeats is 5. Perfect. That's excellent. And that passed. Okay, so now this should be okay. Really, it was just failing because it was blowing up. Part 2 example input 84. Count trees for terrain. What is the problem here? I'm gonna write a couple tests for these, what we expect, because they did give us 2 for this, right? So right 1, down 1 is gonna just run into 2 trees here. So I'm gonna do delta x1, delta y1, and then this should be 2. And then what else did they tell us? 5, right 5, down 1. Delta x is 5, delta y is 1. Delta x of 5. And they told us that this one should be 3. So let's see how these work here, just to find out where is the bug here. So these are working. Write 7, down 1. Oh. 1, 2, 3, 4, 5. Write 7, down 1. We missed one. Wonder if this is what the problem is. I'm pretty confident that the code is behaving the way it should be. There we go. Okay, so it's now. So now essentially we just need to take this and duplicate it, and then we'll just run this on the full input. Handle part2 full input, and then I'm just going to do day3 full.txt. We're going to comment this out, and then just print ln the product here. And that gives us this massive number, which makes sense because we did have a really long input, and so it's going to run into tons of trees. That's the right answer. We did it. Didn't quite beat the caviar, but we got close. I am going to do my usual thing and just clean this up a little bit. I like to format these. Oops. I like to format these just so that they're easier to read. And then this way, if I decide to refactor this down the road, I can still run these tests and confirm that they behave the same way. So, cool. Thank you for watching. This has been part 2 of Advent of Code Day 3. Have a good one.